hello there. This is KP the Math G here, and while my wife is making ready for the day, I'm going to do a video. We were talking about the second derivative, and this is determining concavity and maybe, if there is one, points of inflection. We want to talk a little bit about what concavity looks like. So before we get into concavity, well, I'm just going to draw a very quick. Alright, so this would be, and I would say concave up. Some teachers say opens up and all that. I hope that we get past that in calculus and we say that is concave up. And so, I mean, I like to use the initials CC. Okay, concave, or concave up or concave down. In this particular case here, we are at concave. Okay, there we go. That would be concave down. Okay, that's it right there. Alright, so very rough sketches here. Alright, so just to get an idea of what is concave up, what is concave down. So that's what we're talking about here. What is a point of inflection? Okay, and unfortunately I have magnets that try to come out of my eraser. Alright, we will consider this G function here in just a little bit, but I just want to give you an idea of what all this is. Here's a point of inflection. We call it a P.O.I, point of inflection. So we might call that a P.O.I, like that. Alright, so what would be a point of inflection? Well, let's see, from the looks of that would be something that looks like this. Okay, so you have something going like that right there. And we know that this portion from here to here is concave down. And if we call this a function of L, then this portion right here is concave up, and the point of inflection would be right in between where that starts to become from concave down to concave up. We call this a point of inflection. And one important thing we need to know about a point of inflection is that the concavity does have to change from concave down. That is, if F we say prime would be the first derivative, double prime would be the second derivative, and we say is negative. Here it has to change sign. So this would be negative, okay? And f prime at x is greater than 0. This has to change sign. If the sign changes from either minus to plus or from plus to minus, we have a point of inflection. I would like to say, and I haven't studied it as frequently as I should have, or as much as I should have, but I do believe that it would be preferred that I believe that the function has to be differentiable. That is, you can take the derivative of it, but also when we say differentiable, it is continuous. But not all functions that are continuous are differentiable. For example, well, I mean, there's no point of inflection. Okay, so let me give you an illustration of one does not have a point of inflection, and then we'll get in with our lesson here. Okay, something like this does not have a point of inflection. We'll call this G. If you notice with this function here, okay, you have something that is concave up. If there is a point of inflection, it would be here, but if there's not, because, okay, G double prime at x is certainly greater than 0, but this G double prime at x is also certainly greater than 0, and there is no sign change, so there is this point right here, whatever this point is not a point of inflection. Okay, so just kind of get an idea behind those things there. Okay. All right. Now, remember that when you're doing this, remember that the first derivative, what does it find? What do you find when you're looking for the first derivative concerning graphs? You're looking for where G increases or decreases. Okay? It increases if G prime is greater than 0. It decreases if G prime is less than 0. It makes sense, doesn't it? So what we want to do is, first of all, let's take a little time to draw this graph. Okay, I already have it drawn, but I don't have it drawn up here, so let me take a little time off to the side. It's going to have to be a little bit small because, well, you know, I need room to work with this first and second derivative here. And there are ways that we can just test this, you know, without drawing the graph. Okay, but I like to get a little picture of this. The graph of it looks something like this. It behaves, I'm just going to put down -1, 0, 1, 2, and 3 here. Okay, so it's going to do something like this. It goes way out, and it comes down to 0. Oh, I'll go ahead and graph with black. Okay, it comes down to 0. It goes out like this, and it's kind of curved. It's not a straight line. Then it comes up from, I want to say at 2, it goes up to 1, 2. I wish I had this drawn already, but I don't, but it's okay. I'm put 4 right about here. At 2, I want to say there's a turning point right here. Right there, and it comes up to 4, and it kind of has a little curve here. Then it comes down. I want to say it goes through 3 like that. Let's see, 3 squared is 9. 3 times 9 is 27. 3 cubed is 27. 27 plus 27 is 0. So yeah, it does go through this number 3 right here. Okay, all right. So right there, it goes through here. All right, but anyway, if you notice, you have in this function, it is decreasing. We see that it is decreasing from -infinity to x equals 0. It is increasing from 0 to 2. You have what you call a horizontal tangent here and here. So right here in this area between, in this area here, this region, whatever you want to call it, okay, on this interval from -infinity up till 2, you have concavity upward. So this is concave up, this is concave down. Okay, these two have horizontal tangents, which means there is a min here at x equals 0 and a max here at x equals 2. Okay, 0 and 2 being what we call critical points. Alright, so that's the graph of that. And then I want to graph G prime if it's possible to graph it here, and then graph G, and then our G double prime, and just show from that what these look like. And so let's look at it. It's a pretty simple problem. This is what we're considering for today. Alright, now let's take G prime at x. Remember, we're looking for this is the slope of the tangent line to the curve, and we're looking for where is G increasing or decreasing. We don't say where is G prime increasing or decreasing. We say where is G increasing or decreasing. Well, we've already seen the picture is really clear, isn't it? Let me erase this so we can have some room here. Okay. All right, let's go ahead. G prime is, we all know what this is. This is 6x minus 3x squared. Okay. And what we can do right here, I'd like to find out where these where this tangent line is 0. Where the slope of the tangent line is 0. This represents the slope of the tangent line to this curve right here. Okay, so let's set this equal to 0. And we're going to kind of solve a little bit. Okay. So if we do this, then we're going to say that let's take out 3x. That's going to leave us with 2 minus x equals 0. Alright? And notice something here is as we solve. This means that if a times b equals 0, then a equals 0 or b equals 0. Okay. Alright, so if we look at that, then we have if we divide by 3, we have x. If 3x is 0, then x is 0, or x equals 2. And if we notice here, this is where those horizontal tangent lines are, aren't they? Okay. I have not looked at, well, I don't have the graph of that drawn. So, if you will excuse me just for a minute. Oh, excuse me. Okay. I have a calculator for this. Okay. So let me, just a minute, I'll get to it. Okay, so let's see, I've already drawn the graph. As you can tell, I've already put that on the, I do believe that's the correct one. Yeah, 3x squared minus x cubed, okay, and here is the graph of that right there. That's what I did here. So what I want to do here is I want to do y equals, I want to come down to y2. I want to graph the derivative of that, 6x minus 3x squared. Okay, that's what I'm doing right there. I want to draw the graph of that. It's going to be a parabola because it is squared, but this parabola is going to go down because this is a negative sign in front of the coefficient, in front of the lead, well, the coefficient here, the x squared coefficient. Well, here it is. I'm going to draw it. There it is right there. And so what we are seeing here, and now let me give everybody a picture of this. Okay, so the graph is roughly, let's see, bear with me just for a minute as I look for the max on this one. Okay, let's see. Let's see. Okay, no, I don't want to do that one. This is it. There we go. Okay, let's see. And then okay, it is at 1 comma. Okay, so the graph is at 1 comma 3. The max is here. It goes through here, and let's see. I want to see where the intercept is. I want to say that it's going to be at 3. Let's see. 3 times 6 is 18. 3 squared is 9. Well, no, that's not right. It would have to be another number. It's probably 2. Let's see. Hold on. Bear with me just for a little bit. 2 times 6 is 12. 2 squared is 4. Yes. At 2. Yes. Okay. It's going to be here. And that's a good reason. Okay. It's going to do something like this. Okay. It's going to come down. Up. And down, and that's pretty much the parabola there. Okay, I didn't draw this on purpose. I wanted to wait and draw it later so all of us could see what's going on here. Okay, so what does this mean? All right, this is G prime at X right here. This is the graph of G prime, so this is G prime right here, whereas this one here is the one in black. If I can get the black marker. Okay, this one is G right here. Okay, so we did have, you notice that the turning points are at 0 and at 2. Okay, so this just simply means where is G increasing and decreasing? It is definitely decreasing from negative infinity. So we're saying decreasing from negative infinity to 0. All right. Remember, as long as the graph is below the x-axis, G is decreasing on this first derivative. Okay, when we're looking at the first derivative. Okay, decreasing. All right, it is increasing from where? From 0 to 2. So increasing from 0 to 2. Okay, and also decreasing from 2 to negative 2, positive infinity. We're going out to positive infinity, so it is decreasing again from well, in this case here, from 2 right here to from 2 to positive infinity. So one thing you might want to ask your teacher, professor, okay, if you box in, I say if you include 0 on the decreasing, do you include the 0 on the increasing? And the same thing with 2. If you include it on the increasing, do you include it on the decreasing? I don't know what answer there is to that, and I will try to figure that out. I will try to learn something more about that. I believe I have a comment section. You can comment on that if you would, and I certainly would appreciate that. Okay, so this is showing where the graph is increasing and decreasing. I do want you to take the note that we do have a high point right here appears to be at 1. We're going to look at that when we look at the second derivative, okay? So let's take a look at it, okay? Let's take a look at that. And I think on the next video I'm going to take this very same problem right here and do this and show you how to test this without drawing the pictures, okay? Without drawing the pictures. It does help to see the graph, doesn't it? Below the graph, decreasing; above the graph, increasing; below the graph, decreasing. Okay, so that's what we're talking about here. If you just want to find out where it's decreasing, this is all you need here. If you just want to find out where it's increasing, this is all you need here. Okay? Okay, so let's move on. Alright, I'm not going to talk about that now. Let's look now. We have the first derivative. I'm going to have to erase this because I want to put everything on one side. Okay. Thank you for being patient with me. I do appreciate this. My wife is probably being patient with me right now, saying we got chores to do. And yes, we do. And I'm not trying to avoid the chores, okay? Alright, so maybe I am, okay? Let her know that, okay? Alright. G double prime. That's the second derivative, okay? So this is where the concavity is, concave up, concave down, point of inflection. We are going to have a point of inflection on this problem here. Got a nice, real smooth curve of G here. So we're going to have a nice little point of inflection here. Alright, so let's take a look at it. So let's see. We're going to take the derivative of 6x, which is 6, and the derivative of 3x squared is 6x, and we're going to set that equal to 0. Okay? We want to know where exactly that point of inflection is, and the way to do that is to set this equal to 0. Well, this is easy. I'm just going to bring the minus 6x over here and solve it this way. 6x equals 6. Obviously here x equals 1. And we can see from here at 1 that there is, if you notice here, there is a high point on f prime, which means that there is a point of inflection here, and that's what we're looking at here. Well, let's do this. Let's draw the graph of this now, G double prime, and let's look at that. I guarantee you that I know what one of the points is right now. It is this. It's going to slant to the left because this number in front, this coefficient in front of x is negative. So we know that the graph is going to slant to the left. Okay, so let's take a look now. Alright. Thank you for being so kind and patient with me on this. I know it's a pretty lengthy lesson. Alright, so let's take a look on the calculator here. Alright, so here we are. We're going to graph y equals. This time we're going to put this in under y3. I've got an old calculator. You may have something a little more advanced than this, but this is what I'm using at the moment. Okay, so let's see. 6 minus 6x. That's what I have in the calculator right there. There's going to be a straight line. And I hope you can read that. Okay, let's put it a little closer maybe. There it is. Let's draw the graph of that one. And boy, we got a whole bunch of graphs here. Okay, like this right here. Okay. Alright, so let's see. I do know that the x-intercept is at 1. The y-intercept is where you let x be 0, so this is going to be at 6. It's going to be way up here somewhere, and I'm not going to plot that up there. I don't think I'm going to have enough room. I can erase my... We've guess I can erase it a little bit. Okay. Ah, come on. Here we go. We know we're talking about the second derivative. All right, here we go. All right. All right, here we go. Let's go on up with our graph. Whoa, okay, so 5 and then 6 right here. The point is up here. There's a point down here. Okay, so I want to plot this in red if I may. Let's see if I can do that. Ooh, let's see. Ooh, I hate trying to plot something I can't see too well. That is definitely as much not a straight line as I can draw it. I guarantee you it is not. It's supposed to be a straight line. Okay, I will try to do a little better. Let's try it again, maybe. I probably should have went a little slower. Just gotta go through one and keep going down. Okay, that's going to be the best I'm going to do with that. I'm sorry if it doesn't look good here, but we do know what's going on here. Above the graph, to the left of 1, we have the graph above the red line, and the red part of the line is above the graph, which means that from negative infinity to 1, the graph, or say just G, G is concave up. Well, look at G right here. From negative infinity all the way to 1, this is where our point of inflection is, right there. Well, somewhere right in there. Alright, so to that point of inflection where the concavity starts to change. Okay, that's what that is. Concave up here. Alright, if you notice after x is 1, we get below the x-axis. So from 1 to positive infinity, we are going in the positive infinity direction, and I hope I did put positive infinity on the last one. This is G is concave down, and that makes sense. If we look at G right here, it is concave down. Okay, and we do have a point of inflection. We found that x does, alright, it crosses the x-axis at x equals 1. So x equals 1 is a point of inflection. So there it is. So there it is graphically. I'm not going to spend time to do this now. My wife will really get on to me saying, we got some clothes to clean, we got dishes to wash, I've got a couple of greenhouses to look at. So, I mean, the greenhouses won't take that long, but anyway. This is what we were wanting to accomplish today, and this does look like a lot. Now remember, the black curve is G. The green one is G prime, which shows what? Increasing, decreasing. Decreasing here, increasing here, decreasing here. Okay? And the red line shows concavity, concave up from negative infinity to 1, concave down from 1 to positive infinity, going this way forever. Okay, and x equals 1 is a point of inflection. Now I don't know what the y value is. We could plug it in and figure it out, but at x equals 1 we have a point of inflection. This is really not a point. We need to say x equals 1 comma something to get that point of inflection. If that's where the point of inflection occurs, is at x equals 1, okay? Alright, I do believe now I have a comment section and I do have a subscribe button, so please, if you will, press that subscribe button and make a comment if you would like to. Okay. Again, this is KP the Math G. I'm going to get back with my wife. She's not really going to skin me alive, but she's probably going to say something if I stay in here too long. So KP the Math G signing off. I trust your day will be a great day. Thank you so much for being patient with me today.